Welcome once again to a portfolio theory video. Portfolio theory number 8. So I want to talk to you about the decomposition of portfolio return variance again. Here is a 26 by 26 matrix, okay? And stocks A through Z. And down here we have the last row. So you can imagine what values would be in a few of these cells. We'll look at a few of them, okay? So here we'd have the weight in A times the weight in Z times the covariance of the returns of A and Z. And here we'd have the weight in B times the weight in Z times the covariance of the returns B and Z. And here would be the weight in C times the weight in Z times the covariance of the returns of C and Z. And then here, last term, we would have the weight in Z squared times the covariance of Z with Z, which of course is the variance of the return of Z. And that's what we have. And so we could consider this bottom row to represent the contribution of security Z to the risk of the portfolio. Contribution of security Z to the risk of the portfolio. And using the same thinking, this would be the contribution of security A to the risk of the portfolio. This contribution of security B, and so on. Now, this way of considering this decomposition of portfolio return variance material, it ends up being quite useful in helping us understand the importance of the covariance terms. Okay, so now I'm going to put a plus sign here, in here, and I'll put a plus dot, 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 and then this term, because we're leaving out a lot. And that's going to represent this last row, the contribution of Z to the risk of the portfolio. And now I'm going to factor out the only term that I can factor out, it's WZ. And then we're left with the weight in A times the covariance of A with Z plus the weight in B times the covariance of B's returns with Z's plus the weight in C times the covariance of C and Z's returns plus dot, dot, dot plus the weight in Z times the variance of the returns of Z. Okay? So, well, I'm now going to show you tell you without proof, that this material in the parentheses is the covariance of the return on Z with the return on the entire portfolio of 26 securities. Okay? That's what that is in the parentheses. Exact same value. Which means that last row can be thought of as the weight in Z times the covariance of the return on Z with the return on the portfolio of 26 securities. And that means that the row above it, that one, would be considered to be the weight in Y times the covariance of the return on Y with the return on the portfolio of 26 securities, and so on. And could do all this down to the weight in A times the covariance of the return on A with the return on the portfolio of 26 securities. And then here we'd have that entire matrix again, which we know that the sum of all the cells in the matrix gives us the portfolio for the decomposition of the portfolio return variance. And what I'm showing you here really highlights the importance of these covariance terms. Really highlights the importance of these covariance terms. They are crucial. They are crucial. And it's very interesting. Spend some time studying this table right here, in that we can describe the portfolio's return variance in this manner also. Okay? In this case, 26 stock portfolio, we have 26 terms that, when you sum them, would give you the another decomposition of the risk of the portfolio's return variance. And this ends up being very powerful because, well, in particular, because of this term right here. The importance of that term right there, which of course is the same as this term here, just for different stock. But those are the things that I want to make sure you understand well, and that's what's coming up next. Because if we were to regress, let's say we have a scatter plot of data, looks something like this. Let's say here we have the return on stock Z, and here we have the return on some market portfolio or market proxy. So simultaneous observations here, okay, of return on Z and return on some market proxy. Maybe we'll pretend that our market only consists of 26 securities. That would be convenient to tie this in to my last example up here. Okay, well, it looks like a straight line might fit this data pretty well. So if we try to fit a straight line of this data, our eyes tell us it's something like that. And OLS regression will tell, in order to identify a straight line that is appropriately applied to a scatter plot, all we need is 2 points. We need the vertical intercept and the slope. And we've learned previously that it ends up that slope, that slope parameter, I'll call it beta here, ends up being equal to the covariance of x and y divided by the variance of x. And to fit our current case, it's the covariance of the return on the market portfolio with the return on Z divided by the variance of the return on the market portfolio, or the market proxy, whatever you prefer. Okay, so I will circle that in, or rather set that off with purple. And so this is the beta that we're estimating. And this, look at the numerator. There's that term again. See that? The covariance of the return on Z with the market. Make the Z a little easier to see. Well, you know what? That didn't do it. I erase the Z. Come back. Give me 1 second here. There we go. Now, so again, that numerator there is what is very, very important. This term right here. Because that is exactly what we saw right here and right here. The covariance of the return on stock with the entire portfolio, and now the entire portfolio is just assumed to be the market portfolio, and we can just pretend it is 26 securities. So the important thing to note here is when we calculate the beta, in this case it will be the beta of stock Z that we're calculating, okay? It would be the covariance of the return on the market proxy with the return on Z divided by the variance of the return on the market proxy, or the market portfolio. And that's the beta of Z, and that's incredibly important You'll recall that the capital asset pricing model is a risk-return model, and it says the expected return on stock Z will be equal to the risk-free rate plus the beta of stock Z times the expected value of the excess return on the market portfolio. The excess return on the market portfolio is simply the, you can imagine 2 columns of data. You have market portfolio, the return on the market. Erase that, sorry. You have the return on the market portfolio. Then you have the risk-free rate. Okay, and then you observe these values, right? You get the data, and then you create a new column. Put it over here, where you have a new variable. It's the return on the market portfolio minus the risk-free rate, and so it's just this minus this, and then you get new data, and then you sum them and divide by n. You sum return on the market portfolio minus the risk-free rate, and divide by n. And that is what this term right here is. The expected value of the excess return on the market portfolio. That's what that is. So this CAPM is a risk-return relationship. Here's the return. Okay. And here's the relevant dimension of risk. Okay. This is the capital asset pricing model. And what this says, notice that on the right-hand side of the equation, there's only one thing that relates at all to B, to security B, and that is this beta. And so the expected return on Z depends, according to this model, only upon the beta of Z. You multiply that by the expected value of the excess return on the market portfolio, add to the risk-free rate, and you get your expected return on stock Z over some period, perhaps a year. So the reason that the analysis up here was so important was that it ties into this calculation of the beta for a stock, which is the only attribute of the stock whose expected return one is trying to estimate or predict that has anything to do with Z, that stock. So we're trying to predict the return or the expected return on Z, and the only thing over here on this side of the equation that has anything to do with Z is the beta. And that beta of Z has a lot to do with, by definition, the covariance of the return on the market and the return on Z itself. Okay, so that there makes it clear how important the covariance items here are, and knowing that will serve you well. Okay, and that's a big advantage of understanding this decomposition of portfolio return variance formula very well, because you really feel comfortable when you start talking about the beta of a particular stock and how that fits into the analysis for the capital asset pricing model, okay, which is, again, the model that people often use to predict stock returns over the next, say, year.